Okay, now we're going to work on simplifying the square root of a whole number. So let's say we just have a whole number in there, but it's not a perfect square, right? There's no number that when you multiply by itself gives us 28. So to solve this, or to simplify this, what we should do is we can look, and ideally, if we could spot a perfect square factor, meaning if we find something that multiplied by another number is a perfect square, we can think of it, we notice that 28 is 4 times 7, right? So we can break that down and we can say, well, that's 4 times 7. Now, we see that 4 is a perfect square. So if we break that down to the square root of 4 times the square root of 7, you know that the square root of 4 is 2, right? So square root of 4 evaluates out to 2, and then we still have a square root of 7 here. Okay, so this is if we recognize a perfect square factor. Square factor. And if you know your factors and you're comfortable with recognizing perfect squares, this might, if you see that, that would be the quickest way to solve it. But let's say you didn't. Let's say you didn't recognize at first that it was 4 times 7. And you broke down 28, and you said, well, 28 is, let's see, square root of 28 is equal to, we'll say 2 times 14, right? Then you look at 2 and 14, you think, well, I don't have any perfect squares there. So let's go ahead and there's a way that we can, okay, so let's say we didn't spot a perfect square. So let's do it this way. Actually, I'm going to go ahead and erase this. Let's just take 28, and I'm going to break that down. We said it was 2 and 14. And then I can break down 14 further, right, to 2 and 7. Now I've gotten to my prime factors, right? So I have a 2, a 2, and a 7. So this way will always work if you don't, regardless of whether or not you recognize a perfect square in there. So I can rewrite my 28 as 2 times 2 times 7. Okay? Now the idea of a perfect square is I have two numbers that are paired up, right? I have 2 2's. So what I can do now, let's say I have something inside the square root and something outside the square root. Because I have 2 of these, right? I have a pair. I can pull out one of them, right? And then they both go away. Once I have a pair, I can pull them out because that's what the idea of a square root is. And then the 7, I don't have anything that matches that 7, so that one has to stay inside the square root. So my final answer is 2 times the square root of 7. And if you look, these two ways, we're going to come up with the same answer. So even if you don't recognize a perfect square factor in there, don't worry. If you can always break it down into the prime factors, right? And you can pull out the pairs. You can pull out 1. Whoops, I'm at prime factors here. So we always want to get it down to our prime factors. And whenever we see a pair of them, we can get rid of them from the inside the radical and just pull one of those numbers out. Okay, let's try another example. Let's say we want to simplify the square root of 50. Now if you know your factors and you know your perfect squares and you're very comfortable with that, you can recognize immediately that 50 is the same as 25 times 2. And we see that 25 is a perfect square. Right. So square root of 25 times the square root of 2, and 25 evaluates to be just, square root of 25 is just 5 times the square root of 2, right? So there's our answer. But let's say we didn't and we broke down square root of 50 into 5 times 10. And now I look at that number and I think, well, neither of those are perfect squares. But remember what I said, we can break down 50 into the prime factors, right? And you know that 10 is 2 times 5. So let's rewrite this as the square root of 5 times 2 times 5, right? And remember what we talked about, if we have a pair on the inside, that's the perfect square. That one can come out. These both go away. And what we're left with is the square, 5 times the square root of 2.